So we are back to our 5-3 notes. This is the second part. I had to do a little break in the middle. We had a family emergency. We are solving trig equations. I'm on example 6. And on this one, we did kind of a weird thing and we squared both sides. And I said that this was one of those tricks that you would never know to do, except the only way that we can sub sine for cosine or vice versa is if we have something squared, if we can use those Pythagorean identities. And the only way to get a Pythagorean identity is to square. So we squared both sides. And then when we squared the sine of x, we have sine squared x. We'd move the cosine to the other side. So now we have cosine squared x plus 2 cosine x plus 1. That was to keep the sine away from the cosine, so we didn't have anything where it was sine and cosine together. And then we substituted for sine squared x. And then I want to get everything on one side, so I'm going to subtract 1, and I'm going to add cosine squared x. So now I have 0 equals 2 cosine squared x plus 2 cosine x. So I can see that really clearly on this one. We'll factor a 2 cosine x out of both sides, or out of both terms. So 2 cosine x times cosine x plus 1. And we will solve with zero product property. So dividing both sides by 2, it's still 0. 2 is just a constant. I don't have to worry about it. On the other equation, I have negative 1 equals cosine x. So these are all going to be kind of unit circle ones because it's 0 over 1, negative 1 over 1. So whenever your r is 1, remember we're not really building triangles. We're just looking at those points like on the axes. And my cosine is x over r. So I need to think about where x is 0 or where x is negative 1. So here's this, here's my unit circle. So right here at 0, my x is positive 1, so that's not going to be it. Right here, my x is 0. So x equals 0, my y is 1, my r is 1. So that's going to be one of my angles. Over here, my x is negative 1, and my y is 0, and my r is 1. And then down here, my x is 0, my y is negative 1, and my r is 1. So I've got 3 different spots. 2 pi is not going to work because 0 didn't work either, and I'm restricting it down anyway. I'm not even including 2 pi. So this angle would be pi over 2. And then this would be pi. And then this one would be 3 pi over 2. And remember, because we did some squaring and we substituted at the beginning, we do need to go back and check our answers. So we're going to do an answer check. And when we check pi over 2, that means, remember, we have to go back to the very original problem. And this one's a lot easier to check than the last one. Our original is sine x minus cosine x equals 1. So we will just have sine pi over 2 minus cosine pi over 2 equals 1. And so cosine pi over 2, that's my y value at pi over 2, so that would be 1. Minus cosine pi over 2 is my x value at pi over 2, so 0. So the first one's going to check. And then we're going to check pi. So sine pi minus cosine pi equals 1. So sine would be like my y when I'm looking at points on the unit circle. So my y value at pi is 0 minus cosine. So my x value at pi is negative 1. So 0 minus negative 1 is 0 plus 1, or 1 equals 1. And then I'm looking at 3 pi over 2 minus cosine 3 pi over 2 equals 1. So now we're looking down here. So my sine, again, when I have a point on the unit circle, it's always over 1 because my r is 1. So I just need to worry about my y value. So negative 1 minus, and my x value right here for cosine would be 0. And so negative 1 does not equal 1. And so we can't have 3 pi over 2. So our answers here are going to be x equals pi over 2 and pi. And remember to start with, because cosine has a period of 2 pi, we were looking at all 4 quadrants. But we had answers that did not work. So we just have pi over 2 and pi. So this is now the end of our 5-3 notes.